If you haven't done so yet, make sure you pause the video and try to answer this question on your own first before listening on. We can see that the question is asking us to determine the electric current that's intercepted by the total surface area of Earth. We know from this chapter that electric current is symbolized by lowercase I, and it's equal to the total amount of charge that flows past a given point divided by the total amount of time that the charge takes to flow past that point. Charge is measured in coulombs, and time, of course, is measured in seconds. The question states that about 1,500 protons are flowing for each square meter of Earth's surface per second. And so we can begin to write the current as 1,500 protons divided by 1 second. Now, of course, protons is not the correct unit for charge. As we noted, it has to be in coulombs. But if we multiply by a simple conversion factor, we can get the charge in the correct unit. We know that 1 proton carries 1.6 times 10 to the negative 19th coulombs of charge. And so the protons in the numerator will cancel with the protons in the denominator, and we end up with a value of 2.4 times 10 to the negative 16th coulombs per second. Now, of course, coulombs per second can be simplified to just an ampere, which is a capital A. But that would represent the electric current, again, for each square meter of Earth's surface. So this would be amps per meter squared. In order to figure out the electric current intercepted by the total surface area of the planet, we're going to have to multiply by the surface area of planet Earth. Now, Earth is roughly a sphere, and we know that the surface area of a sphere is 4 pi times the radius squared. Now, the radius of Earth is approximately 6.37 times 10 to the power of 6 meters. So we're going to be plugging that value in for the radius. Now, dimensionally, if we look carefully, we can see that the meters squared in the denominator are going to cancel with the meters squared in the numerator. And so we can pick up our calculators and process this calculation. Don't forget to square the radius, of course. When you do this, you should get an electric current of approximately 0.122 amps. And this would represent the total electric current intercepted by the entire surface area of Earth. Thanks for watching the video. If you liked it, please subscribe so you can stay tuned for additional videos. Remember, you can send in a picture or full text of your question to the email address that is shown on the screen, and I'll do my best to post the answer to it on YouTube.